session in this subject. So I like the students or the participants to be more participative or more discussion oriented, so that when they leave this class after 1 hour, their doubt, whatever they had, the questions of whatever level, even the simplest one, about the blockchain technology would have got cleared. So I can propose one thing, like I go in a one way dialogue for about 45 minutes, and then the last 10 minutes we leave for questions and answers. Or do you want it to be any time you want to know the means answer to your doubt or question? I think Dr. Inderjit, you can guide me on that. Okay, thank you, Doctor. So, with that, let me start with this presentation. The total, you can say, name, it includes blockchain, IPv6, and Web3, and all these combined. And these are the emerging technologies in addition to AI and IoT, which you may already know. So, combined thing, I have called it also the Internet of Wealth. Actually, blockchain, the industry name is Internet of Value. But if you add more technology to this and converged way, then you get what is called Internet of Wealth. And that is what you will see here. As I mentioned, it will be very basic part to start with, actually. And I always start my all classes on digital transformation by quoting from the UN World Telecom and Information Day theme of 2122, and that was regarding digital transformation, and it talked about various technologies, blockchain being most prominent among that. So that is why I also start with that in any of my class, but that will be a 2 minutes introduction, and then we go to the blockchain fundamentals. And during this, one thing you have to become very clear without doubt is you should know the difference between blockchain and Bitcoin. Actually, the Bitcoin is well known, blockchain is not that much known. 90% of the people who know about Bitcoin, they think blockchain is Bitcoin. And that difference has to come out very well. Actually, both are different. Then how the blockchain works, what are the different protocols, how you build trust with blockchain, what are the salient features, and what are the new developments, challenges, and also some of the use cases. So for today class, I think we will be able to complete only about 60 slides out of my 140 slides deck, which needs 3 sessions like this. So let me go now. This basically the theme of UN 2 years back was not just digital transformation. That is a known thing. Everyone is moving towards that, whether it is a country or a company or a entity or a individual. He has to digitally transform itself, and that is a talk being going for last 5 6 years. And 2 years back, UN got concerned about that. The speed of digital transformation was not what it was expected to be, and that is why they made the World Telecom and Information Society Day theme of 2022 as accelerating digital transformation, actually. So first of all of us have to be very, very clear what actually we mean by digital transformation. That, of course, everyone knows, everyone is doing. But real thing about digital transformation is it is nothing but incorporation of computer-based technologies. I call it ITification or softwareization in an organization, product, processes, strategies to better engage and serve. And it is also equivalent to empowering the workforce and customers so that they can achieve better productivity, ease of working, and quality of experience. So that is what is the practical meaning of digital transformation. So it is touching everyone, everything, and every activity, main theme being to achieve better productivity, ease of working, and quality of experience. And there are so many things, but in the same theme, the ITU also mentioned about the UN Connect 2030 agenda, because 2030 is a year when the 6G will come. Actually 6G will become a reality, and for that UN itself have come out with the UN Connect 2030 agenda, which talks about emerging transformative technologies, and we know all of them, and blockchain of course is one of them. What are those emerging transformative technologies? It starts with 5G, Wi-Fi 6, now Leo, Satcom, IoT, M2M, RFID, nano satellites, Industry 4.0. That is what you all know, which is a combination of AI, AR, VR, ML, robotics, everything comes in Industry 4.0. And then these new emerging technologies where IPv6 comes, new internet, and blockchain, which you will be learning today. Blockchain actually is known as distributed ledger technology and also known as Internet of Value. And then you go further and further to Web 3. So I had made the three C's for digital transformation. I call it three C's for digital empowerment. So you have to keep that in mind, these three C's. The first C is about the technology part actually, and that is the connectivity. So what is required for digital transformation is a high speed, secured, robust, always available end-to-end connectivity to all from anywhere to anywhere to enable work from anywhere. And that is where we got during COVID, actually 5 years back, this concept of work from anywhere. Earlier it used to be work from office, then we started doing work from home, but now the need is work from anywhere, wherever you are, even if you are on move, even if you are in a park or a road, work from anywhere. And for that, at least in India, you have Digital India, BharatNet, PM Warning Vision, CSC, MHSP, IPv6, all these things are actually helping in that. The high speed, secured, always available end-to-end connectivity. So that is first C of digital transformation. The second C, the content, and that is what has become very, very important actually, and that is where all our apps actually, and the biggest stack of the content on the digital side, which is helping in digital transformation. And blockchain is also one of them. It is also a type of internet content per se, actually a data. So India stack actually, you all have to know India stack actually. India stack is India's own software development, own products of software which are used to deliver public services. So many things like NPCI, e-Rupee, Aragya Setu, Cowin, MyGov, UPI, Beam, Bharat Pay, and many more actually, JAM, GM. All these things put together are the content, and they are basically clubbed under what you call a India stack, and it is running over the connectivity. So connectivity is required, then the content is required. And third C, that is very, very important, and this class is a, let us say, a step in that direction. Capability, or you can say skilling for the do it yourself, DIY, like that is conditioning, adaptation to the technology, reskilling, upskilling, multi-skilling, and there are so many initiatives of the government. So because you may have the connectivity, you may have the content, but if you don't know how to make use of that, because now you are working from anywhere, you may not be in your office. Like this class, I'm speaking from my home only, and so unless I know how to use the connectivity and content, I would not have been able to deliver this talk to you. So that is the capability part, the training, skilling, education part actually, and that is what your NIR actually is trying to do. So that is what I wanted to bring, and this of course is not for this class. I had authored a poem on blockchain. The name of this poem is called Blockchain Chalisa actually. It title is Blockchain Ek Sunehri Kadi, or a gold chain internet of wealth. I'll not be spending much time on that. It is a 40 liners on the blockchain, what it is, what it can do, and where we are. So I'll be skipping it. And I'm now coming to our main agenda for today's class, that is, what is blockchain? It is also known as Internet of Value. Actually, blockchain is a digital infrastructure wherein a distributed digital ledger is maintained by a network of computers or nodes. Actually, a network of computer is also internet, is also a network of networks, and blockchain is also a digital infrastructure. Basically, it is also known as distributed ledger technology. So it's, there are ledger, there is data, but it is distributed. So in this, information of a financial or non-financial transaction, it is related to transaction. Because what is a ledger? In the ledger you put the transactions, what are called entry also. So the normally in the ledger, in the typical way, these are all financial one. But when we are talking of blockchain, it is not limited or restricted to only financial transaction. Even non-financial transactions are also put there, and they are validated by the nodes of validators, and that is a value addition of blockchain, the validation, whether they are true or not, and that mechanism is called consensus, which will be seen. Blockchain infrastructure not being managed centrally, because it is decentralized, it is distributed, so it effectively reduces the chance. Yes, please.
मम्मी पापा दोनों आए हुए हैं। हाँ पक्का 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 है ना। हाँ
Okay.
अरे एक्चुअली मम्मी चाय इलायची मांग रही थी, तो मैंने इस समय घंटी भी बज गई नीचे से, मेरे से बात कर ही रहा था, तो पहले भाई के लिए खोलने गया। अब बड़े घर में दिक्कत है करूँगा।
Yes, I am trying.
नहीं मैं पक्का बोलता हूँ बाबू, पक्का। ओके
Okay, sir, shall I continue? Yes, so blockchain infrastructure not being managed centrally because it is decentralized effectively reduces the chances of data manipulation, because if there is a central control, central person there, and he can do some manipulation knowingly or even unknowingly of the system, and neither it will be inefficient, because any central control or any middle layer you add in any infrastructure, so it makes it inefficient and add to the cost. So if you can remove that, so then it becomes efficient. But how you can remove that? What the role a central agency or a middleman plays, that is the trust. They bring the trust actually, like banks, they bring the trust in money exchange. The government,
आवाज नहीं आ रही क्लियर,
bring
दोबारा लगाओगे मेरे को
the
जरा।
trust in the government. So,
Okay.
no, thank you.
Hi,
Thank
sir.
you. So it brings, and that is the main thing about the blockchain, it brings transparency, traceability, and trust to the transactions. And how it is done, you will see through immutability and cryptography. Cryptography is the main thing. And I'll be coming to this diagram soon, a look at blockchain technology, but you have to know little more about the definition, and you will see that of the previous block. Hash is like a checksum. a timestamp and transaction data. Actually, some data is there, the hash of the previous block is there, and a timestamp, and that is very, very important because that is used to decide the ownership or provenance of a particular information or a particular transaction. It is an open distributed ledger that can record transactions between two parties efficiently, between two parties and on a peer-to-peer basis in a verifiable and permanent way. So you don't need a middleman or a auditor or a controller. So automatically it can be verified also, and it is permanent also. It is immutable actually. So a little bit about the history of blockchain, though a lot of you may be knowing about that white paper of 2008, peer-to-peer cash. The paper was written by a pseudonym or fictitious name called Satoshi Nakamoto in 2008. He improved the design by using hashcash-like method to timestamp blocks without requiring them to be signed by a trusted party and introducing a difficulty parameter to stabilize the rate with which blocks are added to the chain. So some incentive also. So that is how the blockchain came to in the public domain, though as I mentioned here, blockchain-like protocol was first proposed by a cryptographer, David Shom, in 1982, actually. But it actually became application-oriented or started being used in 2008 by that white paper of Satoshi Nakamoto, which created the Bitcoin. That was the first application of blockchain, actually. It is mentioned that the design was implemented by same Nakamoto as a core component of a cryptocurrency called Bitcoin, where it serves as the public ledger for all P2P. P2P means peer-to-peer or one-to-one kind of transactions on the network without involvement of a central trust authority. That was the whole theme of the 2008 white paper. And now, how does the blockchain works actually? So as I told you, it is basically transaction distributed ledger technology, which is storing and sharing the transactions. So first, someone requests a transaction, means that it can be just request, or it can request for some money or request for some sale, or let us say it is a few lines of a email. So the requested transaction is broadcasted to a peer-to-peer network, and that is the blockchain. So it is there, which is consisting of computers known as nodes actually. So there is a blockchain, let us say blockchain, Bitcoin is a blockchain, and there are a lot of nodes connected to that. If someone wants to make use of Bitcoin blockchain to do some transaction, so he will request there and it will go to all the nodes. Then the network of nodes validates the transaction and user status using known algorithm. And that is the blockchain software, you can say, actually, for algorithm and consensus. It will be coming. So that is the blockchain layer on your normal infrastructure of the internet. So ultimately, it is also a OTT kind of thing, or a content over the internet, the blockchain. So you have internet, you have nodes, you are connected to the internet, and now you want to make use of the blockchain to do some transaction to a third party without involving any, you can say, medium or internal or central controller. What we do today actually. With blockchain, you want to have a direct transaction, and that also should be verified, immutable, and that is what the validation thing. So if it is validated by the majority of the node, a verified transaction can involve cryptocurrency, tokens, contract records. So it is not about the coin or money only, anything actually. So once verified, the transaction is combined with other transactions to create a new block of data for the ledger. So it is first it is received, then its hash is generated, and then it is validated by using a algorithm. These algorithms are also called consensus mechanism, and there are different which we'll be seeing. So then the new block is added to the existing blockchain in a way that is permanent and unalterable. So whatever data once comes on the block, blockchain because it is cryptographically encrypted, and also there is a hash, and the hash has a linkage with the previous block also. So that is where it becomes immutable, and then this is added to the block after validation and after creating a new hash, and the transaction becomes complete. And that is what happens to each transaction, and that is how the block keeps adding and it becomes a chain. The same thing is described here also actually, but just for the purpose of repetition so that you become very clear. So blockchain based DLT system take the form of an append only. Append only means you can only add, you cannot alter or change or delete a block actually. New addition to the database are initiated by one of the members, actually nodes. You have to become a member of the blockchain to become the node there. So like suppose you are a user, you want to use a blockchain, so on your mobile or on your laptop you will have to create a wallet. Like if you are knowing the CBDC, that e-rupee of India, which is CBDC, so you have to create a wallet on your mobile, which, and then you become a member actually. In this case your KYC is done, but in some cases even KYC is not required to be done. So you'll see when it is required, when it is not. So that is how the information about new data block is then shared across the entire network containing encrypted data. So transaction details are not made public. So that means it is encrypted. So it is only known to the people to whom it is meant actually. Though through hash, it is shared everywhere. So all network participants collectively determine the block's validity according to the predefined algorithm validation method. It is also called consensus mechanism. It is a highly technical and bit complex thing. Maybe in the first class you will not know how it is done, but it is a algorithm. Only after validation, all participants add the new block to their respective ledgers. Through this mechanism, each change to the ledger is replicated across the entire network, and each network member has a full identical copy of the entire ledger at any point of time. So this is what I wanted to bring. What exactly is the meaning of blockchain? Now, what are its salient features? By now, you would have known blockchain is a digital ledger that stores transaction details. These records are stored in containers, which are called blocks actually, because it has the content and then it has a hash and it has the destination address to whom this transaction has to go, because it is peer-to-peer communication. These blocks are linked to each other through hashing, and that is what I mentioned. The one block, when it is received on the network, so a hash is created, and that hash is the replica, and that tells that what is the information in that earlier block, and then the new block with validation is created, and they are secured using cryptography. So the salient features of blockchain are the data is available for everyone to access. Data can be added, like block can be added, but cannot be altered. So it is append only. To add data, validators, which are also called miner in some of the blockchains, have to verify the transactions. The transaction have to be approved by majority of the network. That is 51% what they call. So if the majority of the network are approving it, then only it is added to the chain as a next block. No central authority is there actually or has control over the information. Privacy is protected by cryptography because data is synonymized actually, and that is where the cryptography helps. So these are some of the salient features. Now, as a beginner, you have to also know the blockchain ecosystem. Blockchain ecosystem means all the stakeholders of blockchain. Blockchain as a ledger technology, that is just a ledger technology. It's a technology, but it is not just a technology. It is the technology of technologies, and then it has the users nodes. So there are different, let us say, components or modules of the blockchain. And these are listed here, the transaction. That is the starting point of blockchain, any transaction. Then there are immutable blocks. Each transaction is converted through containerization by adding the hash into immutable blocks. Then there are decentralized peers, and these are the node. Then you have a distributed computer network, and that is your internet basically. And then you are using encryption, cryptography, key distribution, because for cryptography you have to encrypt and decrypt, so keys are required, private key, public key. Then there is a consensus mechanism to bring the trust or the validation. Then there are some apps called smart contracts, which are very, very important now. Then there is something called DFs, decentralized apps, DeFi, DY. There are so many component of the blockchain as a ecosystem. There is a concept called DAO, decentralized autonomous organization, and then blockchain cooperatives. Actually, these days you can have a blockchain cooperative where members manage public entities. So there is a no common manager or the chief executive. All the members, like in a trust, they do something like that. So these are the ecosystem, and some basic building block again are a part of the ecosystem. The starting building block, the DLT.
97 वोट दे पाया मैं। वो 3 वोट पिछला वर्कशॉप में हम लोग घर।
So DLT is distributed ledger technology, I think you know, and blockchain, which is called distributed ledger, an immutable distributed database, that is log of blocks, which are interlinked through hashes and cryptographically encrypted and replicated on all the nodes. So that is your blockchain. The block, a digital container, data packet for transactions, contracts, property titles, ownership, assets, so many things. It is not only about the currency part. And blocks are secured using public key encryption. The code of each new block is built in that of the preceding block through hashing. That is called checksum also. It guarantees that it cannot be altered or tampered. So that is why immutable. The blockchain is viewed by all participants nodes. So it enables validating the entities in the blocks, and privacy is maintained through pseudonymization of this. And this is very, very important to actually understand the blockchain ecosystem. So I've named it 5 pillars of blockchain ecosystem actually. So the starting point actually is the database, the distributed database. So it is here, nothing is centralized. So everything is distributed. And then you use what is called public-private key cryptography. So first, you have a distributed database. Then you use the cryptography. So these 5 pillars are like that. And then you also make use of the hash function for the immutability, so that it is something like checksum. And another, and that is the most important part, is consensus algorithm. That is the validation part actually, and how you do the validation so that the single proof of truth is brought out. And then the decentralized processing. Decentralized processing means there is no centralized processing. And the difference between distributed database and decentralized processing is anything which is decentralized have to be distributed, but distributed may still have a centralized processing. You can have a master computer and then there are nodes all along and you have distributed, but then there is a single master controller, single authority. So here the control is decentralized. There is no single entity to control or manage everything. So that is why these both are different. Distributed, decentralized. Decentralized is always distributed, but distributed does not mean it is decentralized. That is why both these elements are brought here. And decentralization, that means no single point of control, is a very, very important pillar of the blockchain ecosystem. And these 5 pillars I have also tried to make in 5 layers actually. As you know, it is a internet of value. And internet, you know, our normal internet had 7 layers, the famous OSI 7 layers, starting with the physical infrastructure going up to the application layer. So like that only we have tried to put the blockchain architecture in similar layers just for the purpose of interoperability or standardization, and because ultimately it is making use of the internet only, so we also have to have a correspondence between those layers. So the first layer is called hardware or infrastructure layer. Actually in internet also it is called physical layer, but which is nothing hardware. Physical means hardware actually, just for the simplification purpose. So these are virtual machine, container, services, messaging, whatever you have your public internet or IT infrastructure. So that is the starting point of anything you do in IT and also in blockchain. Then you come to the second layer, and that is called data layer. Like in internet also we have a data link layer, but here you have data structure, digital signature, hash. There is a Merkle tree, that is a mechanism, consensus mechanism, transactions, so all that. So the blockchain layer is this data layer actually. First you have a internet layer, which is your physical IT layer, and then you have a blockchain layer, and on top of that you have a network layer. And here the network basically means peer-to-peer communication. So it is not that you are going through a switch or a router. It has to be peer-to-peer communication, and that is a algorithm for used for blockchain, so that there is no centralized authority or no middleman or no layer in between. So that is there, and it is getting achieved now with IPv6, which is also a emerging technology which have already come, where each device or each user will have its own address. Because for peer-to-peer communication, one-to-one communication, you need an address. Like in phone you can have a one-to-one call, but in case of internet, if you are using a previous version, IPv4, internet protocol v4, then so many addresses are not there. So what they do, they use what is called NAT, network address translation. So maybe for one office only one IP address is given, and then it is reused among the 100 nodes, 100 computers, or lot of devices there. But in case of blockchain, you need peer-to-peer communication, hence a individual or a dedicated address, personalized address to everything which is connected on the blockchain. And then you have the most important part of the blockchain architecture, and that is called consensus layer. Actually it is an algorithm. There are different way of consensus, like the famous one was proof of work, POW. Then there came proof of stake, then denial, POS, then POET. So many are there, but you have to remember the basically debate is going on the first two, proof of work. The first one, which was Bitcoin, was proof of work. Then Ethereum came, that was also proof of work. Now it has gone to proof of stake. Proof of stake is becoming more important because proof of work consumes so much electricity, and that has brought the bad name to the blockchain also, that it is very you can say eco unfriendly, environmental unfriendly, lot of power consumption, pollution, carbon credit. So that happens in POW, consensus layer, the proof of work. But if you go proof of stake, then it is not that much actually, it is very little. And then the real thing comes, the top layer, application and presentation layer. These are the top 3 layers of the normal internet. They have been put together, and that is where you have various apps like smart contracts, chain code, DApps, user interface. That API starts from here. So if if someone is having a blockchain and any user can through API starts making use of that, they can develop their own app, and that is called blockchain as a service. And that is what is happening actually. Everyone does not have to create its own blockchain. Blockchains are already there. So through APIs, through application layer, you can start making use of application of blockchain and also create your own use cases. So these two slides are very, very important, the 5 pillars as well as 5 layers actually. And this is just a basic thing, that how the distributed or the decentralized peers work. And immutability, it is very, very important part of blockchain. As with the existing database, blockchain retains data via transactions, because all data is basically transaction. The ledger is a type of transaction. The difference is that once written to the chain, the blocks are extremely difficult to change. You cannot change them because of the hash. If you change, then hash will not match, and everyone will not be able to validate. So that is why it is called immutable or indelible. So in other terms, blockchains are write and read only. Are write and read only, that is append only. So you cannot change it actually. And it is similar to our what we write in the book actually, bookkeeping. So whatever you have written now, you cannot alter it. It will be found out. So you have to add another entry or another line there, that earlier one had mistake and now this is the real one. So similar thing happens here. So you cannot change any of the entry or transactions there. And how it is done? It is done through encryption and cryptography. There are standard encryption practices. You can do your own also. Lot of things are there, and that is a separate subject in itself, but it is the main pillar of the blockchain. And then this consensus mechanism, which is an algorithm for doing the validation. So it ensures the next block in the blockchain is the one and only version or proof of truth actually. And that is the trust. Trust is coming through this consensus mechanism. When majority of the people agree, yes, this is the next one. Keeps powerful adversary from derailing the system actually, because otherwise in internet and everywhere these frauds are happening, cyber security issues are there. So to avoid them, we are using consensus mechanism. And as I mentioned, there are many, each one have its advantage and disadvantage. Proof of work is what I mentioned, proof of stake, these two, POW and POS are main, but there are many other are coming. And this is another information which you should know actually. As blockchain is a distributed ledger technology, so but there is a similar thing without blockchain also actually. Blockchain is using the cryptography, and though it is also a distributed ledger technology, and all the advantage of distributed ledger technology like decentralized as trust, efficiency, immutability, all are there. Then there is a similar technology called DAG. You should know that. Nobody normally mentions about that when he's learning about blockchain. Directed as cyclic graph. It is a mathematically interconnected structure that consists of vertices and directed edges that never form a directed cycle. In the case of DAG, based DLTs, the vertices often represent transactions or blocks, and the edges represents parent-child references between the transaction or block. They can do almost similar thing, what the basically DLT does, like what a blockchain does on the DLT. So DAG is also a type of DLT, what blockchain does, because sometimes people are not happy by using crypto, or they are not comfortable using crypto. Like in India also, if you know, our RBI, they were creating their own cryptocurrency called CBDC. CBDC is central bank digital currency. So they have done it. They have done wholesale and they have also done on retail. But till now, nobody knows actually whether they have used crypto or they have used DAG. So that is what. So there are alternatives to crypto. So blockchain is crypto, but you can do a similar job what blockchain does through other computer mechanism called DAG. So that information should be known to all of you actually. And now why blockchain? Actually, we are running out of the time, of course, but my idea was just to give you a basic flair of what blockchain is, what it can do, and we are almost coming there. So you have seen now the 5 pillars, 5 layers, but what blockchain actually brings to the table, as in the beginning I mentioned, it brings transparency, traceability, trust, these 3T, and 4T to the transaction. So transparency, traceability, and trust to the transaction. So what happens by using these things? So you can reduce the cost, you can bring the efficiency because there is no middleman, no trusting agency actually. Increased efficiency, increased security, actually very important, the security, because when you talk of internet or cyber, so the security is always under doubt. Reduced fraud also, though they say blockchain can have fraud, but it is other way around actually. Your normal internet or normal application on the internet can have fraud, they are already having fraud, but if you use blockchain, frauds are not there actually, it is other way around. Reduced risk is also reduced because there is no single point of failure. So these are some of the salient feature. If you want to use at least one of them, so then also blockchain is justified to be used. Suppose you want to reduce your cost, why you will not like to reduce your cost? So even for that also blockchain is justified. That is what I am talking about, the promise of blockchain. Why everyone is talking about blockchain? Because it has so many advantages. Some advantage you will always like to grab. These are some more capability, the same thing what I've told, but now I will have to run a bit fast. This is about trust building, how the trust is built through consensus mechanism. Here each node is actually made as a witness. There is no central guys. So if the majority of nodes are telling yes, it is the true thing, so then they are the witness, and hence it becomes the trusted thing. And then it also have a timestamp actually. So this is how the trust is built here. Blockchain attributes I have already explained. So again, we can show increased trust, because trust is through data here. It is not just a human want that yes, it is okay, but it is proved by data through a algorithm, consensus mechanism, which is crunching the data actually. No single point of failure, so hence reliability, like in internet also. Efficient, consistent transaction between participants. So that is where I mentioned transparency, traceability, and trust to the transactions, the 4T. All these salient features are written again, which helps actually to use the blockchain and become more efficient, more transparent, and more reliable actually. Normally there are two types of blockchain, public blockchain and private blockchain. What you are hearing or reading is public blockchain, that is Bitcoin was the first one, then Ethereum came, Litecoin, all these are mainly used for cryptocurrency, but they can be used. And then there are private blockchain, they can be enterprise blockchain, they can be government's own blockchain. So these are the company internal. So public blockchain is open P2P network, participants can join, leave, no KYC there, so large scale distributed ledger. But private, these are permissioned, identified, trusted participants, KYC done participants, and regulated control and all that. Each have their plus and minus like given here. In a public blockchain, ledgers are visible to everyone on the internet, and anyone can verify and add a block to the transaction to the blockchain, which are well-known example, Bitcoin, Ethereum, Dash, Fatcom. Then private blockchains allow only specific people in the organization to verify and add transaction blocks, since all permissions are kept centralized to an organization. But everyone on the internet is generally allowed to view, like multi-chain, block stack. And then there is a consortium that is in between actually. controlled by a consortium of members, and only predefined set of nodes have access to write the data or block. There are examples: Ripple, R3, Coda, Hyperledger, which is very, very popular actually as a part of consortium. So there are some limitations of the public blockchain and private. These are the classifications. So we will not go much in detail now, because I have to come to some real and this is about the native currency, which you should know, and that is the cryptocurrency like Bitcoin, and new currencies are coming. So you also have to know this thing actually. Our country have a national strategy for blockchain, which is created by MIT, Ministry of Electronics and IT, and they have a national blockchain framework. Another, these 5 layers kind of thing, which I've taken from them. So there is a chain layer, the shared ledger, over and above your infrastructure layer. So the blockchain layer itself, the data consensus, is done in 3-4 layers here actually: amplified, platform layer, smart contract layer, access layer. So this is for the purpose of standardization. So if you create a blockchain in India, you have to follow the standard architecture basically, so that interoperability comes. So this is in the public domain, and government is supporting any usage or any development work on this, and they are funding it also. Now, blockchain use cases, actually, just one slide I'll be talking. There are generic opportunities on blockchain. Smart contracts are there, digital currency, their record keeping, securities, everything you can talk, the blockchain can help actually. Till now it is more used for the currencies or financial or fintech, but it can be used for so many things like healthcare, title records like land records, ownership, again land records, voting, intellectual property. So it is not only financial thing, but also so many things, because wherever record keepings and certificates are there, the blockchain can really help actually. So whole plethora of industries can make use of blockchain. So that is what is shown here. So it is not about the currencies alone. The smart contracts can help in notarization, digital rights, escrow, trustees, and then record keeping. Everywhere record are to be kept actually: intellectual property, voting, ownership, everything. So that means blockchain have the never ending applications which can be imagined, and more are coming day by day. So it benefits all the sectors actually. And the digital assets are some more use cases. One of them is very important. Those are called token, and you should know about NFT, non-fungible token actually. And that is what smart contracts attribute of blockchain can be used to create a new type of digital assets. Because one are the coins like those bitcoins and all that. We are not talking about that. They going. The other thing, you can convert your digital assets through tokens actually. So instead of coins, and the tokens make it more liquidated and more identifiable, and ownership is verified and timestamps there. That is what everyone is using. So this also, I think, I have to go to now. This Bitcoin was the initial blockchain use cases. Will not go. In fact, the next class will be how the blockchain works. That is another very, very, you can say, interesting thing actually. So you will know actually how it works. So that today we are not discussing, and these POW, the proof of works, those consensus, they are a part of how the blockchain works actually. So what I have to bring you is not today, at least I have to immediately bring you to there are a lot of applications like these certifications which you will not be able to have time today. But one thing which is very, very important, I have to bring to you, so that you will start learning more and more about blockchain, is Web3, because that is interrelated. So basically, integration of blockchain, 5G, AI, IoT, and IPv6, all these emerging technologies, if you put together actually each one and where they meet each other, the cross section of all the technology give what we call Web3 actually. And the Web3, you are already knowing that it is the future of the web. It is, I have named it worldwide owned wealth. Owned wealth is the main thing which blockchain brings to the table. So worldwide web, of course, we all know. Earlier it was read only, then it became read, write, then metaverse we are there, and worldwide web 3 will become ownership, read, write, own. And that is what I have shown in this diagram, which will be my last slide actually.